Alright, tonight we're looking at 3 by 3 or bigger matrices and finding determinants of them. And what we're going to need to use is this thing called a sign matrix. And all the sign matrix is just positive or negative values. Or really, we don't want to say positive or negative, but really the same or opposite. And all you do for a sign matrix, the top left entry of your matrix is always positive. From there, you just always alternate. So when I go to the right, I make it negative. When I go down, I make it negative. Everything must alternate. If it was a 4 by 4 matrix, for example, I'll just expand this a little bit to see what a 4 by 4 would be. Last entry here was positive, now it's negative, so this guy would be positive, negative, and then this guy down here, the signs would be like so. So all that matters is that you're always alternating, never having positive and negatives together. So let me just go right into an example of showing you how to do a determinant of a 3 by 3 matrix. All you're going to do is you're going to pick one row or one column, it doesn't matter which one, and you're going to do like so. Let's say I pick the top row as my example. What I'm going to do, I'm going to first take a number. So that first number there was 4. 4 is in a positive spot in the sign matrix, so I keep it positive 4. What I then do is I eliminate that row and that column that the 4 is in. And what I'm left with is a 2 by 2 matrix. And I'm going to take the determinant then of that matrix that's remaining. So negative 2, 4, negative 2, negative 6. Okay, that's using the first number. I then go to the next number here, which was 3 in that row. Well, 3 here is in the negative position of my sign matrix, so I want the opposite sign. I want it to be a negative 3. And I'm going to do that negative 3 times the determinant of whatever matrix is left when I cross out that row and column. So that matrix left would be this 5, 4, 3, and negative 6. And then my last one here, negative 2, it's also in a positive position. That doesn't mean I turn it positive. That means that it stays the same that it is. So negative 2 times the determinant of whatever's left. And when I cross out that column with that row, what I have left is 5, negative 2, 3, negative 2. So let's first find the determinants of all of these matrices. So this here, negative 2 times negative 6, like we did in the last lesson, this should be 12, and then minus a negative 8, so 12 plus 8. So this is a determinant of 20. This guy here, 5 times negative 6 is negative 30, minus 3 times 4 is 12, so this is a negative 42. And this guy here, 5 times negative 2 is negative 10, minus 3 times negative 2 is negative 6, so I should get a negative 4 as that determinant. So what I have now here is 4 times 20, and I have minus 3 times negative 42, and I have a minus 2 times negative 4. When I simplify that, this guy becomes 80, this guy becomes plus 126, this guy becomes plus 8. So my answer here for my big determinant is going to be, what does this become? This should be 214 as my big determinant. Let's look at another example here. I'm going to do the same idea. I'm going to take this row right here, and I'm going to do one step at a time. So this is going to be equal to 1 in the positive position times the determinant of what's left. Well, I've crossed out that row. Let's not cover up my negative sign so don't forget it. The 1, first row, and the first column. So what I'm left with is the matrix 1, 3, 2, 5. Now, this guy here is in a negative position of our sign matrix. That means I flip the sign to be a positive 1 times the determinant of what is left. And again, what we have left here when I slide this guy over is going to be the matrix 0, 3, 1, 5. And then when I move over to the last guy, 2, which is in the positive position in that first row, times the determinant of what's left, which is 0, 1, 1, 2. All right? So what I'm going to do now is each individual determinant. So I have 5 minus 6 here, so this is negative 1. I'll have 0 minus 3, so this guy's negative 3. And this guy is 0 minus 1, so this is negative 1. So I have 1 times negative 1 for the first part, 1 times negative 3 for the second part, and 2 times negative 1 for the last part. So I should have negative 1 plus negative 3 plus negative 2. So my determinant here is negative 6. All right, now that's not the only way for me to look at a determinant. I don't have to use just that first row. I can use any row or any column that I want. So just for example, let's use instead the first column instead of the first row and see what ends up happening. So I'm just going to draw a line here and do it a different way. So when I do that, get rid of some of my excess lines here, get them out of here. And I will have, with that first row, or first column I should say, this is going to equal, first guy's still the same, still 1 times the determinant. I'm going to get rid of that row and column, and I'll be left with the 1, 3, 2, 5 that I already had before. That's the same as I did before. Now, when I move down to the second number in that column, that number is 0. So 0 times the determinant of what's left, which is negative 1, 2, 2, and 5. And then my last guy is going to be in the third position. It's in a positive position. The guy that's left, the determinant of that matrix, negative 1, 2, 1, and 3. Well, first what you should notice here, after you do this determinants all here, is that I have 0 times a determinant of something. Well, 0 times anything is just 0. That whole thing's going to go away. This makes our job a lot easier, because now only we have 2 determinants to determine. So, in this guy, we already knew this was negative 1 for this determinant. So 1 times negative 1 there. And this guy here, we should have negative 3 minus 2. So that's a determinant of negative 5. So 1 times negative 5. And when I add those up together, I should get negative 6 as my answer, the exact same as what I had before. So really, what I should be doing here is looking for rows and columns that have a lot of zeros. So for example, I could give you a 4 by 4 matrix like this. Now what you could do is you could use this first column and say this would be, 1 times the determinant of 2, negative 1, 4, 0, 2, 0, 0, negative 3, 2. And then subtract 2 times the determinant of whatever's left there, which would be 0, 1, 0, 2, negative 3, 5, and 0, 2, negative 1. You could go through this entire process with all of this. This would be now minus 1 determinant of, this would be 0, 0, 0, 1, 0, 2, 0, 1, negative 1, and minus 4 determinant of 0, 0, 2, 1, 0, negative 3, 0, 1, 5. You could do that. That would be very, very cumbersome, very ugly, to say the least. What I'm going to do instead is say, where do I have a row or column that has lots of zeros? Well, check out this row right here that has 3 zeros in it. That means all I'm going to have to do is it's going to be, well, this is in a negative position, so I should say negative 0. That doesn't make much sense, but negative 0 times the determinant of whatever's left when I take out that row and column. Well, who cares? 0 times anything is 0, so I don't even care what that is. When I go over to this column, it will now be plus 0 times the determinant of, well, I still don't care because it's 0 times something, so I don't worry about that. Now in this entry, now I have negative 2 times the determinant of something. Well, this one actually I do care about because it's not 0 times something. So my matrix that's left when I do that determinant is 1, 2, 4, 1, 0, 2, and 0, 1, negative 1. And then the last guy is going to be plus 0 times the determinant of, well, really, again, I don't care because it's 0 times something. So all I'm looking at is this guy, 0 times the determinant of that matrix. Well, I'm going to have to do more of this kind of like row reduction sort of thing to be able to figure out what the proper answer is. Well, I'm going to use this entry right here, that column, just because it has a 0 and it has 1s, which are easy to work with. So when I do that, all I'm looking at is this part right here, because everything else has gone away. So I had the negative 2 out in front. I'm going to multiply that then by, okay, this 1 is in the first entry, it's in the positive entry, times the determinant of what's left when I get rid of that row and column. So that'll be 0, 2, 1, negative 1. I'll then subtract, because I'm in a negative position, by 1 times the determinant of what's left, which would be 2, 4, 1, negative 1. Then the last guy in the 0 position, I'm not even going to worry about because 0 times anything is 0. So I have negative 2 times whatever these guys end up being. Well, this determinant here is 0 minus 2, so that's negative 2, so that's 1 times negative 2 here. And this guy here is going to be negative 2 minus 4. So this will be 1 times negative 6 as that determinant. So I should get, right here, when I have minus and negative becomes plus a positive, so I should have negative 2 times, this is negative 2, this is positive 6, so this is times 4. So that means my answer here is a determinant of negative 8. And it looks really ugly to do, but it's a lot easier than trying to do all these extra steps and finding a determinant that way.